So we're going to talk about hyperbolas. So I know this is a hyperbola because it has both the x squared and the y squared terms, and one of them is negative and one of them is positive. That makes this a hyperbola. So I'm going to get the equation in standard form for a hyperbola. So to do that, I take the positive squared term first, and then I have another y term, and then I take the negative squared term, and I have another x term. And then I bring the other term, the constant term, over to the right. Change the sign. All right, now I take out the coefficient outside of the parentheses, and I think about what I would distribute 9 to if it was here to get negative 18y. So I can see that would be negative 2y. Then I put my blank for completing the square, then minus 4. Another coefficient, I take it outside the parentheses. So I have to look at that negative and how that would distribute. So in order to figure out the term that comes next, I have to think about negative 4 times something gives me 16x. Well, I can see that that's got to be negative in order to be positive 16x, so it must be negative 4x. And I could check it. Negative 4x squared, yes. Negative 4 times negative 4x, yes. Now I put my blank for completing the square. And then over on the right, I have my 43 and my 2 balancing blanks. So I can balance the numbers that I need to add on these lines so I can create these perfect square trinomials in these parentheses right here. So then I take my middle term, 2, divide by 2, square it, so that's 1 squared, so that's 1. And then on this one, 4 divided by 2 is 2, 2 squared is 4. All right, so I need to balance those numbers by putting a number over on this line and this line. So I didn't only add a 1, I added 9 times 1. And I added negative 4 times 16. So over on the right, I've got 9, which is the 9 times 1, and negative 16, which is the negative 4 times the positive 4. All right, so now I'm ready to write the factored form of my perfect square trinomial, which is y being the square root of y squared. Square root of 1 is 1, and the sign is minus. And then I write my little 2 squared. All right, now here I'm going to bring down the minus and the 4 from in front. Now I need the factored form of this perfect square trinomial. So I get the x from the square root of x squared, and the square root of 4, 2, I put that here, and my sign from right here. Now we've talked about this many times before, how I can check and see that I believe that this is the factored form of this perfect square trinomial. If I multiply y minus 1 times y minus 1, which is y minus 1 squared, and combine like terms, I can get back to this. All right, so this and this are equivalent. All right, now I add up those numbers on the right-hand side, and I get 36. So I have 36 on the right-hand side of the equals. Next, I go ahead and divide by 36 for every term, so I can get the 1 that I want on the right-hand side. So remember to look at your formula sheet to see what standard form for a hyperbola looks like. All right, so now I reduce 9 over 36, so that's a 4 in the denominator. and I reduce 4 over 36, so that's a 9 in the denominator, equals 1. All right, so this is the form I'm looking for. So from here, I get that my center is 2, 1 in the same way. Looking at right translation, 2, that's positive, and a right translation, 1, that's positive. So let's put my center over on my graph at 2, 1. All right, so next, I look at the bottom numbers here, and I can see that a squared is 9, and b squared is 4. So that means a is 3, and b is 2. Square root of 4 is 2, square root of 9 is 3. So what that tells me is where I'm going to put my construction lines. So in the y, I'm going up 2 and down 2 from the center. So over to the graph, up 2 and down 2 from the center. And in the x, I'm going right 3 and left 3 from the center. And then what I do with that is I draw a rectangle with these dimensions using dotted lines. So there's my rectangle. And then what I do after that is I draw the asymptotes, which extend from the center through the corners. So those are my asymptotes. All right, so from there, I can sketch in the branches of my hyperbola. So you have 2 branches. So you need to look at the first term in your equation. So right here is my first term. My first term is a y term, and so what that tells me is that I'm going to cut through the y axis with my branches of the hyperbola. So I'll show you what I mean by that. I start at the vertex right here, and I go out toward the asymptote, and then from the vertex out toward the asymptote in this direction. And then my second vertex right here, I'm going to draw the other branch in the same way. From the vertex out. Okay? So those are my branches of my hyperbola. The next thing I'm going to do is I'm going to find my foci, and my foci will lie inside the dishes. So let's just put them there temporarily until I get the actual count, the number of squares that I need to count. Okay? So to get the foci, I need my formula from the formula sheet for calculating the foci. So the formula says that c squared equals a squared plus b squared. So for the ellipse, this was a minus. For the hyperbola, this is a plus. I haven't derived these formulas for you, but these are derived from the geometry of the problem. So now I know a squared is 9 and b squared is 4. So I can say that c squared is equal to 9 plus 4. That's 13. So square rooting both sides, I can see that c is the square root of 13. So the square root of 13 is between the square root of 9, which is 3, and the square root of 16, which is 4. So for our purposes, for the accuracy level of this type of graph, we're just going to say it's between 3 and 4, 3.5. All right, so that gives me a better idea of where to put my foci. So you count from the center approximately 3.5 units. So from the center, 1, 2, 3.5. So it's pretty close to where I want it there. So this is one of the foci. And then in the other direction from the center, 1, 2, 3.5. So roughly right there, in line, as you can see, with the x-coordinate of the center. So these three will be in line here. Alright, so now if I want the coordinates of my foci, I'm going to have two ordered pairs. So like I said, the x-coordinate would be 2, same x-coordinate as the center. And now that I know that that distance, the distance I'm talking about, square root of 13, is between here and here. So I start at the y-coordinate of my center, and I go from 1 up root 13. So the way I would write that is 1 up, so that's plus root 13. So that's my y-coordinate in exact terms. All right, no decimal approximations. And then 1 minus root 13, which means I'm starting at 1, I'm subtracting root 13 to get to this y location here. Alright, so I've got my foci now. And now the next thing that I want to record are the vertices and the co-vertices. Okay, so we already mentioned that the vertices, which is plural for vertex, are these two dots right here and here. These two dots are actually on the hyperbola itself. This red line is the hyperbola, this one here, this red curve. Alright, so I need those two dots. Okay, so those two dots, let's do this one first. This is x, 2, y, negative 1. And this one here is x2, y3. And the last thing I want are my co-vertices. And those are these points here on the side of my rectangle in line with the center. Those are my co-vertices. So these are the co-vertices. I'll just say co so you can see. And the ones that are actually on the graph itself, the red graph, are called the vertices. So let's look at the coordinates here. So this one is at 5, 1. So 1 is the same y-coordinate as the center. And this one here is at negative 1, 1. And then we're done. So the things that we've recorded, we have the equation in standard form here. We have the center, the foci, the coordinates of the foci, the coordinates of the vertices, and the coordinates of the co-vertices. So looking at the graph once again, these dotted lines are the asymptotes, and the box, those are construction lines, which are not actually part of the hyperbola. The hyperbola itself, this is the two branches, this one here, this red branch here, and this red branch here. That is the hyperbola itself. Okay, so this is the center of the hyperbola. These are the vertices of the hyperbola, actually on the graph itself. The co-vertices are on the sides of the construction box in line with the center. And the foci are always inside the dish in line with the center. A distance of square, in this case, c was square root of 13, a distance of c from the center. Now this example will be a hyperbola in the other orientation. So once again, I know this is a hyperbola because it has both the x squared and the y squared terms present, and one of them is negative. Okay, unlike when we talk about the ellipse, we always say that these two coefficients have to be different numbers, but that's not necessarily true for the hyperbola. So the distinguishing features are that you've got both the x squared and the y squared terms, and one of them is negative. All right, so I'm going to organize my equation. So let's put the x squared first, then the 32x, then the y squared, and the negative 6y, and the other term subtracted over to the other side. Now, another thing that I want to mention is this is also very important, is that sometimes when you're given the equation, you might be given it in an order such like in this equation here that we have, perhaps those first two terms were switched like that. Okay, what you want to do is switch them so that your first term is the positive term and your second one is the negative term. That way our rule that we use for determining the way it cuts through the orientation of our drawing, our graph, holds. So put the positive squared term first, and if you do it that way every time, you'll get the hang of the graph pretty easily. Alright, so now I'm going to complete the square. So I'm going to take my coefficient outside the parentheses. I'm going to figure out that if I put an 8 here, 4 times 8x is definitely 32x. And then my blank for completing the square. Now on this term, my coefficient is a negative 1. So I take a negative 1 outside the blank, the parentheses. And then if I put a positive 6y here, I can see that negative 1 times positive 6y is negative 6y. So I have to get this sign correct here or everything will be off. So pay close attention to this sign right here because you're distributing a negative 1. Then we need our blank. And on the other side, I have 2 blanks to balance the numbers I have to add in to complete the square. So take an 8, dividing it by 2 is 4, square that is 16. 6 divided by 2 is 3, square that, and you get 9. So I really added 4 times 16, that's 64. So I balance it on this blank. Here, I really added negative 1 times 9, that's negative 9. Alright, so now I combine all those numbers on the right, and I get 4. So on the right I have a 4. So I have 4 times, now factored form would be x plus 4 squared minus 1 times y plus 3 squared equals 4. So square root of 16 is 4, square root of x squared is x, square root of y squared is y, square root of 9 is 3. These numbers all added up to 4. So for standard form of the equation, I'm going to divide through by 4. So that gives me x plus 4 squared over 1. I'll just write my 1. Minus y plus 3 squared over 4 equals 1. Alright, so I have it in standard form. From standard form, I get my center. So I can see this is a left translation in the x and a negative in the y. So negative, negative. So my center will be negative 4, negative 3. Right, so negative 4, negative 3. That's my center. Next, Let's get A and B. So I look at these numbers on the bottom here. So I have A squared is 4. So that means A is 2. I have B squared is 1. So B is also 1. Square root of 1 is 1. So what that tells me is if I look at these Y's over here, that means I'm going to go 2 up and 2 down from my center. I'm finding the edges of my construction box, and then in the X direction I'm going to go 1 up and 1 down, 1 to the right and 1 to the left. Alright, so this gives me my construction lines for the box, which helps me with my drawing. Alright, now I draw my asymptotes out the corners of the box through the center. So asymptotes through the center, out the corners of the box. Okay, so you extend them over the whole graphing region. Alright, so now I know I can draw in the branches of my hyperbola. And if I look at my equation in standard form, I can see that my x squared, my positive term right here, is going to tell me, if we use this rule consistently, the positive term is the term that tells you where it cuts through. So my branches of the hyperbola are going to cut through the x-axis. So my vertex on this side is right here. So right on the edge of the box, cutting through the x-axis, hugging the asymptote like that. My other vertex for the other branch of the hyperbola will be here, and I'll do the same thing. Okay, so those red branches are the actual graph itself. The green dotted lines are not part of the graph. Alright, so the vertices lie, these are the vertices right here. They're on the branches of the hyperbola. So while we're talking about them, let's just go ahead and write them down. So the vertices, the coordinates of those would be in line with the center, of course, so the y coordinate is going to be -3 for both of those. And then the x coordinate on this one is -5, and on this one is -3. Alright, so we have the vertices. So the co-vertices then would be the dots on the center of this side of the box, here and here. So this dot would be at -4, -1. And this dot, this point, would be at -4, -5. Okay, so the last thing we need are the foci. So the foci lie inside the dish. So they're going to be in line right here and right here inside the dish. So approximately there. Let's get the C distance. So I need to calculate the C distance, the focal distance, which is the distance between the center and the focus. Both of these distance we call C. Okay, so now we have our formula from the formula sheet. C squared equals A squared plus B squared. Alright, so C squared, we already said A squared was 4, B squared is 1, so that's 5. So C is an irrational number. It's a root which can't be simplified. Now let me just point out that if you get a C such that, let's say hypothetically we got a C like root, let's come up with one like 42 or something like that. You would want to branch this out. No, that's not going to get Oh, I got one. How about 20? Let's say it's 20. Root 20. Root 20 definitely reduces. You don't want to leave it that. We could say instead, and we would want to say instead, that root 20 is 2 root 5. Okay? This, of course, is not reducible like root 20 was. But if it were, you would definitely want to do that. Okay, so now we know the focal distance is root 5. So we know that root 5 is somewhere between root 4, that's 2, and root 9, which is 3. So we'll just estimate it for our graph, which is not super accurate because the squares are 1 unit. Here it's really a little difficult to get it any closer. We'll say approximately 2.5. All right, so over here, I look at my graph, and I'm going to go 1, 2, 2.5. And then in the other direction, 1, 2, 2.5. Let's see. All right, so that's pretty good. Those are my foci, and they're always inside the dish. So I can see from my graph, and you always want to go ahead and look at your graph to get a, so you're not doing any guesswork here. You can actually count. I can see that these foci have the same y-coordinate as the center, which is -3. So most definitely -3 is my y-coordinate, right in line. And now the x-coordinate, this is my starting point at the center here of -4. I would go in this direction. That's adding root 5. So the way I would say that is -4. Let's make a little more room here. So starting point -4, add root 5. Starting point -4, subtract root 5. That means go to the left root 5. So this one says start at -4 at the center and go to the right by root 5, which we said was approximately 2.5 units. And this one says your x-coordinate starts at -4 and goes to the left approximately 2.5 here, or square root of 5 exactly. And so we have a focus right here. So these are our foci, plural of focus. All right, so that does it. We've got everything we need. So hope this helps. Let me know if you have any questions.